So in today's video, we're going to discuss the T flip-flop. What does T stands for? T stands for toggle. And T flip-flop means output of flip-flop will change with respect to input along with clock signal. So now we will have our black diagram for JK flip-flop. So JK flip-flop has an input J and input K and also a clock. Since JK flip-flop is identical to T flip-flop and J and K are shorted to have a toggle input, we will change this black diagram to a T flip-flop. First, this is our input clock and our input toggle. So sometimes T flip-flop is referred to a single input JK flip-flop. Now this will be the schematic diagram for our T flip-flop. So we can construct a T flip-flop by connecting the AND gates as input to the NOR gate as our latch. So we connect the input of this NOR gate to the output of the AND gate. And this AND gate inputs are fed back with the present state output Q and its complement Q prime to each AND gate. A toggle input is connected in common to both the AND gates as an input. So both AND gates are connected to T. Next, also consider the clock, which are also connected to both of the AND gate as an input. In the T flip-flop, a pulse train of narrow triggers are provided as input T, which will cause the change in output state of flip-flop. So these flip-flops are called also toggle flip-flops. So next, our truth table for T flip-flops. So we have the inputs, clock, and T as the toggle. And our output, which is the Qn plus 1. So let's say our clock is low, then the flip-flop is not going to operate. So whatever will be the value of T, our output will be Qn, or memory. So when the clock is high, T is low, we will have a Qn memory. So when clock is high and the T is 1, in this case we will now have the toggle action output, which will be Qn complement, and there will be a toggling action. So this will be our characterization table for T flip-flop. In this table, there will be a single output wherein Qn plus 1 is the next state. And based on the inputs given, Qn and T, where Qn will be the present. There will be 4 combinations in this characterization table. Qn, which is our present state, and T is our toggle input. When our present state is equals to 0 and the toggle input is set to 0, then the next state will be equal to 0. If our present state is equals to 0 and the toggle input is set to 1, our next state will be equal to 1. If the present state is equals to 1 and our toggle input is equals to 0, our next state will be equal to 1. If our present state is equals to 1 and our toggle input is equals to 1, then our next state will be equal to 0. In this part of the video, we will see our excitation table for T flip-flop. We can only calculate T flip-flop if we have calculated the characterization table and also if we had calculated the truth table. Also, we will have 4 combinations just like our characterization table. In our excitation table, we will base the inputs and the output based on our characterization table. So if our Qn is 0 and our Qn plus 1 here is 0, then our T will be 0. Now, at the second possible outcome, if the Qn there in the characterization table is 0 and the Qn plus 1 is 1, then our T will be 1. Now, let's base it again on our characterization table. Our Qn is equals to 1. Yep, right there. And our Qn plus 1 is equals to 0. So obviously our T is equals to 1. Next, if our Qn is equals to 1, right there, and our Qn plus 1 is equals to 1, then automatically our T is equals to 0. The T flip-flop is toggled when the set and reset inputs alternatively change by the incoming trigger. The T flip-flop requires 2 triggers to complete a full cycle of the output waveform. The frequency of the output produced by the T flip-flop is half of the input frequency. Thus, the T flip-flop works as the frequency divider circuit. So now from a JK flip-flop. So we are trying to simulate this circuit using the electronic workbench. So as you can see, this is made up of NAND gates and a NOT gate here. Also, this is a master-slave JK flip-flop based circuit because a T flip-flop is identical to a JK flip-flop, only that the J and K which makes the toggle input. So we have our switches here, the preset, the trigger, or our toggle. We have 2 switches for the clock and for our clear. Also our time with 10 Hz and our oscillator here. Of course, our source. So we will try to simulate this circuit and switch on the preset, the clock, and the clear. So we'll press first the switch here. So as you can see, the output Q and the output Q prime are blinking. And now let's on it. And now this is our output. Thank you for listening. Thanks.